The next thing I want to address in my target is the number of vertices. As you were previously shown, your model is made out of a mesh of triangles laid out to create the shape of your model. Now, for every triangle, there are 3 points, and those 3 points are vertices. As you can see, we've currently got 220,000 vertices in our scene. So what I'm going to do is run a script to clean up those vertices. And to do this, I'm making sure that I have every model selected. I'm then going to clean up mesh. And what clean up mesh does is it takes any loose mesh frames and it joins them together correctly. Often when you export a model from different CAD programs, you'll find that flat and curved faces have been designed in a way that they sit next to each other, but they aren't fully connected. And this will raise the overall triangle and vertex count of your object, making it run less efficiently. So by running this script, we're going to improve our overall performance. So keep an eye on the triangles and the vertices. So as you can see, it's gone from 220,000 vertices down to 160,000. So we've already made good progress. So we've addressed both the object count and the vertex count. The next thing I want to tackle are our triangles. So if I turn on our wireframe, you can see from this wireframe the areas that are most dense with triangles. So if I go to the rear of the hairdryer, you can see from this orange how dense it is, and I'll zoom in. Now, despite the density, you can see that these objects are actually quite efficiently designed. And while there are a lot of triangles in this feature, it's also a feature of the hairdryer that I don't want to damage in any way or remove. So I'm actually not going to add any optimization to this shape here. But if you look at the silhouette of the hairdryer, you can see that this rim piece here actually has a lot more detail than it needs. So I'll run some optimization on it. Now to do that, I'm going to the Optimize menu in our Jig control panel, and I'll press Optimize Selected Mesh. Here we have a ratio slider. Now to start off with, I'm going to begin dragging it down. And you can see the optimization happening to the mesh. And if I go down to 0, as you can see, it gets a little bit crunchy. Now, when I work with the ratio slider, what I like to do is start off at 0.1, which is an optimization of 90%. And I like to have a look at the overall shape. Now, to look at the shape itself and the lighting that's affecting it, I'm going to hide this object's wireframe. And you can see here, we've got some creasing happening that's affecting the shadows of our object. So what I want to do is recalculate my normals. It's automatically set to 27, and I would generally recommend keeping it at that. So I've recalculated my normals, and despite this being at a ratio of 10% in the number of polygons it used to have, you can see that the overall shape hasn't really been affected. Something I am keeping in mind though is I'm looking for any hard edges. So you can see there are some here and in this corner here. So what I want to do is raise up the ratio a little bit at a time. So from 0.1, I'm going to go to 0.2. And you can already see that some of those hard edges on this lip here have already been removed. But if I look carefully, there's still a few more. So I'm going to raise it to 0.3. And there's just a little bit of creasing up here that I'd like to remove. So I'll try it at 0.4. And overall, it's smoothed it out quite nicely. And I'm pretty happy with the overall shape. So I'm going to hit apply. But before I do that, I thought I'd just show you. At a ratio of 1, we have 340,000 triangles. but when I lower this down to a ratio of 4, it's down to 327,000 triangles. So we've lowered our triangle count by running this ratio. So if I hit apply, we've lowered the overall triangle count of our model here, but there is some more work that we could do. And if I press tab, I can see that the mesh has changed and it's looking a lot more messy, but you won't be able to see those lines when working in the Jig workshop. So the overall shape is what counts in the end. Now I'm conscious that this switch here is also a very high polygon object. It's got a lot of triangles in the scene and a lot of edge loops that aren't adding to the overall shape of the object. So I'm going to select it. I'm going to hide its wireframe just so that as I run this optimization, I'm going to be basing the ratio slider on what I see visually. So if I start off at 0.1, you can see it's getting some strange shadow information here. So again, I'm recalculating my normals. What recalculating normals does is it takes the lighting information from your object and recalculates the lighting in our blend scene. Often when objects are exported from CAD programs, the lighting is baked in. So that's why when we run our optimization, we're finding that it's creating those shadowy artifacts. So with our normals recalculated, I can see there are some hard lines in our scene. I'm going to clean those up by raising up our ratio to 0.2, but I can still see some on this edge in here. So I'll try that at 0.3. And it's looking pretty good. There are some hard lines here. Generally, I would say that they're so small they're unlikely to be visible, but just to be safe, I could raise it up to 0.4, and you can see it's a lot smoother. So I'll hit apply. And something to remember to keep in mind is we also have objects hidden inside our hairdryer. So I'm going to press hide selected, and I'll press hide selected again. And now we can have a look at the shapes inside our hairdryer model. So with these wires here, you can see that a lot of the wires have edge loops that aren't contributing to the overall line of this shape here. So it's a perfect candidate for us to run a bit of cleanup and optimization. So I'm going to scroll down. Our triangle count has gone from 400,000 down to around 300,000. So we've already made some great progress. We've lost about 100,000 triangles. I'm going to perform some more on this one here. So I'll press optimize, and we're going to go from 291 down to 235. So that's made a considerable reduction. But I can see that a couple of these have hard edges, so if I view them in object mode without our wireframe, you can see there are some unusual shapes here. So I'm going to raise that up to 0.2. Already you can see that it's looking a lot cleaner. These shapes are looking pretty consistent, so I'm happy with that, and I'll press apply. So we've gone from the top 400,000 triangles down to around 250,000 triangles. So we're making great progress. I would tell you to continue on until you're happy with the overall shapes of your objects, but you've lowered the triangle count as low as possible. Another useful feature of the JigSpace control panel is the ability to show backface culling. I'm going to select that now. So our model now appears to have a different material on it, but another thing that it's also revealed is if I zoom in and go down, this piece at the bottom of the hairdryer appears to be transparent. It's as though I'm looking through the object to the other side of it. Now, this is caused when an object's normals are flipped. So in order to fix this, I'm going to select this object and go to my Optimize panel and press Flip Normals. And now these are facing the correct way, and they'll also face the correct way in the Jig workshop. The next feature I'd like to show is the JigSpace Split tool. So if I go to the Control panel and scroll down, we have our Split tool here. I just want to remove the outer casing or shell of the hairdryer to reveal those internal components. So in order to do that, I'm just going to select my outer casing. I'm then going to choose an axis on which to run my split, in this case the y-axis. And as you can see, I have this arrow here, and I can use that to move my plane around and choose where I want that cut to go through. In this case, I want it to go through right through the middle. So with that prepared, I'm going to press Split Selected Mesh. And now my mesh is split in half. I can select this outer casing and pull it aside to reveal those internal components. This can be incredibly useful if you want to achieve cutaways in your own models, to reveal your internal components and discuss how your model works. In this case, it's also important to remember that by cutting this model into two objects, I've added another object to my object count, and I've also increased the number of triangles and vertices in my scene. But if I find that it's worth it, this can be a very useful tool. So I'm pressing Ctrl-Z to move my model back into position. Now the next thing I'd like to do with my model fully optimized with an improved triangle, vertice and object count is I'd like to export it.